This is my solution to homework number 3 for ECE579, solving the 8 puzzle. So we begin in the main of npuzzle.java. Here we create an n puzzle called test, and then we set up some variables for storing data. So this data is going to be used to read in each of the lines from the input file. Each of these outputs is then later going to be used to provide our solutions to the write out files, where we write our solutions to 3 different text files. This solver is created so that we can solve the problem, and baverage is used to store the values for the branching factors as they're calculated. Solving set 1. So here we have a for loop so that we can iterate through each of the problems, each of the 15 different puzzles that we're passing to it. Those are being passed through this variable called data. So we create a node and pass data to that node, which is using this node class. And one thing I added here that we'll see later is this visited, which I use to keep track of when this node gets visited during the solving. So coming back here to npuzzle.java, this solver calls a method called solve. We pass it node and the heuristic, so 0, 1, or 2, and that's how it knows what heuristic to use to solve the puzzle. These ifs here are just used to print out the branching factors later on. But going back to solve, we can go to 8 puzzle solver, and here we have our solve method. This initially clears everything, all the fields, by calling clear all, which is down here, and it clears our frontier, closed, open, solution, sol, solution depth, nodes visited, and b factor. It does that so that subsequent calls to this don't repeat previous information, or so that they work properly. Back to solve. After clearing everything, we then add the node that we passed to it to the frontier. We then create a curve board, which is later used to compare against the goal board in order to check if we've reached a goal state or not. So this while loop will continue as long as curve board is not equal to the goal board. So as long as we have not reached a goal node, then the loop will continue. Within this loop, we create another node called current node. The current node gets this frontier, the current node gets the node that is in the lowest index of the frontier. And then we calculate the h val, the f val, and then we get the state for the curve board so that we can use that in our equal state comparison here to check if we've reached a goal state. If we reach a goal state, then we'll call extract solution, and we'll pass the current node along with the heuristic that we've been using, and we'll break the loop. And when that happens, we'll go to extract solution down here, where we create another goal node, and that current node gets passed to it as the goal. We then have a string called solution string, which is later used to output the solution. The solution depth gets the g-val, which is basically telling us the depth of the goal node, so we know how deep it went. Then we calculate the branch factor at that solution depth. After this, we create another node called solution, which gets the parent node of the goal node, and this continues until we reach the initial state, or the initial node again. So that's tracing the path back from the goal node to where we began, to the start node. This ends up giving us a solution in the reverse order, so in order to fix that, I use collections.reverse and then pass it this solution. After that, I prepare the strings by including the state, the action, the heuristic that's used, the g-val, the f-val, and the iteration number, so when it was visited. And at the end, I add the goal node, so we can see that that's what we reached. Yep. Down here, the branch factor was calculated by using this equation. And going back to solve, so if we didn't reach a goal node, then we would go into this else, and we would expand a node. So we would expand the current node and pass it the this dot node visited, which is how we're counting each expansion. So that's how I'm keeping track of when that node was visited. After the node is expanded, we iterate through the children and add them to the frontier. We do that by passing them to this method called order, which I have down here. And this basically first compares the incoming child to the closed list to make sure that we don't revisit any nodes that have already been visited. So if we do happen to, if the child matches something that's already in the closed list, then we'll exit this method, we'll return, and we'll move on to the next. If not, then we'll compare the child's f-val to those that are already in the frontier, and if it's lower, we'll place it at the index, at that index. So whatever it's lower than, it'll replace, and the one being replaced gets shifted over to the right one. If that child doesn't have an f-val that's lower than anything that's already in the frontier, then we'll add it to the end of the frontier. And yeah, so I covered what would happen once we solved it. So assuming the problem has been solved, we'll be past this. So we'll be past the solver and get down here to where we're calculating the branching factor for each set. So because there's 15 lines, that p equals 5 will begin set 2. So that's where we will calculate the branching factor for the previous set, print that out, and then reset the b average so that we can reuse this variable for the next calculation. And that next calculation repeats at p equals 10. At p equals 10, we'll do the same thing, so we'll reset it before the last before the last set is looked at. And that's solving set 1. Then this all repeats again for set 2 and for set 3. So here I'll try to show when we run it, we can delete these files. So running this should create those 3 files again. And here we have start of problem set 1. We have the initial state with an action of null, and then the last state is our goal configuration with and we have all the attributes for each of these states listed. So after set 1, we have end of problem set, and then we begin problem set 2. Here we have nodes expanded 39, and again we have start to goal. And this continues until 10, that's the end of problem set 2. Then we have start of problem set 3. And for problem 11, we have nodes expanded 579, and over here in iterations you can see when each of those nodes was visited. It's a little more clear to see now that we have a larger puzzle. So heuristic 2 will have h1 of n. Yeah, so this was h0 of n for outfile heuristic 1. Outfile heuristic 2 has h1 of n and does the same thing, except now we're using h Manhattan instead of h displaced. Outfile heuristic 3 is using h2 of n, and that is h1 of n plus h2 of n. So that does the same thing as the other two, where it separates the sets here and has all the properties for each of those states as the problem is being solved.